Hey everybody, hello and welcome to this presentation. Today we're just gonna show you quickly how to run OpenFOAM simulation on Qarnot's green computing platform. So I already did a presentation last Tuesday for those who were there, but for those who wasn't, we can just let's do a little recap and talk a little bit about Carnot and about numerical pollution, and then I'm going to show you how to do all of that. So just for a little bit of context, Carnot is a company based in Paris, France. We're about 16 employees right now, and we're developing a green computing solution. And just to present myself quickly, I am Tantri. I am the computational fluid dynamics specialist at Carnot Computing. I will be here to help you and to help our clients, our CFD clients, to run their simulation on our platform. And prior to that, I have worked on aerodynamic studies of vertical takeoff and landing aircrafts for urban mobility. And I have a bachelor and master in aerospace engineering from the École Polytechnique de Montréal. So just to get started real quick, today we'll just talk about a bit about the digital pollution, and then moving on to Carnot's computing solution, Carnot Computing's solution to numerical pollution. I will show you the infrastructure behind Carnot, how we use Docker to deploy our application on our computing nodes, and we'll show you how to get started and run some cases. So just to do a small recap for those who weren't there on Tuesday, I was saying that today it is becoming easy to underestimate the impact of technology because it's so widespread in our day-to-day lives. So most of us, we work on computers, we have more smartphones, at home we watch TV, we play video games, and even the infrastructure that makes all of that technology works, well, it's often invisible to our eyes. Like we don't see the cell phone antennas, we don't see the internet cables, we don't see the servers in the data centers. So it's easy to forget the impact of their use of technology. Today, numerical pollution is getting bigger and bigger. It makes up 3.7% of global emissions in the world, which is even more than the aviation industry. And those carbon emissions are growing about 9% per year, which is pretty significant. Then the industry uses rare metal for the production of hardware for like your computers or smartphone. So those rare metals are extracted with a big energy cost, and that can lead to ethical problems in certain part of the world as well. What about CFD and all of that? Well, CFD uses a lot of computational power. The big calculation today are run on clusters with thousands and thousands of cores. And even if the hardware is becoming more efficient and more powerful, well, that creates a rebound effect, and that opens the door for cases with even bigger computational loads. Today, the meshes are already in the hundreds of millions of cells, and we are already starting using more precise solvers like LES. And just to put that into perspective, here's an example of a single rotation of a multi-stage compressor, which was done by Surfax here in France. It took roughly 1,250,000 hours of computing time, and that is equivalent to more than 14 kilowatt hours of energy consumption and more than 4 tons of CO2 emission. And just to give you an idea, that 4 tons of CO2 emissions is equal to about 9 flights between Paris and New York. So what can we do to stop all of that, to reduce our impact when using technology? Well, we can apply a concept called digital sobriety. So just to give you a key points, quickly give you some key points. Use renewable energies when possible. Use powerful hardware, but keep them for as long as possible. You can also optimize everything that you have on the computer, so storage, your code to make it run more efficient, and all of that. You can always develop in modular ways and make everything open source. So when someone or a team develops something, other people that want to use that technology don't have to waste precious resources to develop the same thing. Finally, you can reuse, recycle, and create a circular economy. And that way, what is the waste of some, like in this case, the waste heat that is created by computers, will be the resource of other people. To give you an example, here in France, the data centers, per year, they use about 14 gigawatt hour of energy. And if you take that energy, that waste heat energy, you can heat up to 16 million showers. So here at Qarnot, we have 3 solutions to tackle that last point. The first one are pneumatic heaters. So that's what the name implies. They are heaters that we put in homes and offices and are embedded with processors that heat up when needed. We also have digital boilers. Just give me a minute. I have a small... Yeah, sorry for that. We have digital boilers, which are connected to water circuits in house, offices, and buildings, and they are processors in those boilers that heat up the water that can then be used to take a shower or to cook or everything that uses hot water. Finally, we have computing racks that we put in unused warehouse spaces, and the heat from those computing racks are then used to preserve food and other goods. So just to give you some pictures of our solutions, those are the heaters that we put in houses and buildings, and they are deployed in France and in Finland with more than 1,500 installed units. Then we have the boilers, which are also deployed in France, in Finland for now, and we have more than 40 installed units. And what is the impact of that solution? Well, there is a massive reduction in energy consumption and carbon emission. On the left, you can see we are comparing the deployment in Finland compared to classical data centers. And while there's no energy needed to heat and to cool the data centers, there is massive reduction in energy consumption. As a result, there's up to 78% reduction of carbon emission because we don't need to have all that energy, use all that energy. For the end users, it's also good because it lets us be 2 times cheaper than other cloud providers because we don't have to build data centers, we don't have to maintain them, and don't have to cool them. So just to give you a quick look of the infrastructure behind Qarnot, we have an orchestrator that we call the QWare, and it can intelligently dispatch the calculation where the... Oh, sorry, you can... Thank you. And the QWare intelligently dispatches the calculation where the heat is needed. We are focused on open source software. So for CFD, we extensively use OpenFOAM for the calculation and of course ParaView for visualization. Just to give you a closer look at the QWare infrastructure behind it. So that's how all of this works. There's an API, the Qarnot API, that receives all the calculation, and then it sends them to the Q node. You can see the Q node as like the big boss that has an overlook on all the infrastructure. It knows what needs to be calculated, and it knows where the heat is needed. From those information, it sends the calculation to Q boxes, which are servers that are next to the 3 solutions that we have, which are dispatches in buildings. And those Q boxes can then send the calculation onto the computing nodes. For the data, the users upload their data to our bucket service on storage.qarnot.com, which is based on Ceph technology. And then when the calculation is started, the data is sent onto the Q box for the calculation. Everything is encrypted, and on the computing nodes, there is no storage. So the node is started, the calculation is done, and after it is we shut them down and we erase everything on it. So the data goes back to the client, but we don't keep any data ourselves. You can connect to Qarnot in many ways. Yeah, there's an API, of course, and there are SDKs also in Python, C#, Node.js, and in command line, which you can use to write scripts to connect to the API. And we also have a console, which is pretty user-friendly, and we can use to launch calculation, upload data, and monitor all of that. So at Kernel here, we use Docker technology to deploy our application on our calculation nodes. So why do you use Docker instead of virtual machine? Because there are a lot of advantages to using Docker. First of all, there is no hypervisor needed. So Docker is a lot more light and uses a lot less, far less resources. Docker, compared to VM, can be started in a matter of seconds compared to minutes. And the big selling point is that Docker, well, it's in the name, it's a container that can be standardized and can be deployed on any kind of hardware. So I will talk about it in the next slide, but a client can bring their own Docker and it will work easily on Kernel's infrastructure. Let me see, let's take a break to see if there are any questions. No, there are not, no questions, so I will continue. Of course, our version of OpenFOAM, we have a Dockerized version OpenFOAM of the recent versions. So at the same time, the foundation, the .org with the v 2012, for example, and the v8 and the v7 also. Even if the client never used Docker, that's not a problem. We have a tech team here that is there to help you create a Docker image and even customize it if you're using non-standard OpenFOAM libraries. And like I said, you can pull from any public or private registries, whether it is the Docker Hub or another server. Oh, sorry. So let's see how we can use all of that. So let's move to the computing website. So here is the computing website of Qarnot Computing. You can find a lot of information here. Our clients that uses Qarnot Computing, and you can go straight to the simulation part, and you can find more information that is used for CFD or FEM or other types of simulation. You can find the pricing, our height security standards, and our contact information. It is from the computing website that you can also access the documentation if you have some questions, want to learn how to use Qarnot and all the things you can do with it. So here is the documentation, and you can move on also to the registering page. So I have another tab for that because I already signed into my account, but this is the website where you can register. When you register, you have 15 euros of free credits, which is around 60 hours of computational time. And you also get 10 gigabytes of storage to get started. Just a note on the billing, we bill per second, and there is no fees for the time that the calculation is started on our infrastructure. So you just pay for the execution time, and there are no fees also for transferring data onto our servers. So let's move on to the account when you have registered. So I will do sign in. Just see. I am sorry, I just had a bug. Yes, I was showing any slides, And I don't think there was. Okay, I think now my screen should be shared. So
yes, yes, it is.
Yes, thank you. Sorry for the little bug. So I was moving on from the registration here. I was talking about the registration, and when you're done registering, you can move on to the console and the account. So right here, you have all your account parameters. This is your token. You can find your token here, and it's really important because you're gonna use that to launch calculations on Qarnot. We also have two services. We have rendering, which is one big part of Qarnot computing. So if you ever want to render stuff on Blender or Maya or other software, you can go right here. Or if you want to do fluid simulation or other kind of calculation, you can go straight to the console. So this is the console. So I will close all of this. So what is the console? It's the main web page where you can find all the information about your calculation, where you can launch them, where you can upload data onto your buckets. I will talk about profiles later. So yeah, that is your working space on Kernel. I will talk about the tasks. So what are the tasks? Those are the calculations that you launch. When you do that, they will appear here with the status. So I already have three calculations that were successful. So I will open the OpenFOAM demo calculation that I launched. And inside the task, you have a lot of information that you can find. Here is the standard output. So it is what you normally find on your terminal at home when you launch the calculation. So they all exported here. If you have any errors, they will appear here, so you can debug your calculation. And there is also a JSON with all sorts of parameters on the instance and all the calculation. For example, here we have the results, which are all the outputs of this is the PITS daily tutorial. So I have all the outputs. You have all the information about the instance. So let me find them. You can see the processor, the running time, the execution time, the wall time, and the states, and all kinds of information. Here on the left, you can see, again, all those information right here. You can see the buckets that they use to launch the calculation and where the results were output. Finally, on the bottom, you can see information on the Docker container that you use for the calculation. So here I pulled from our own Kernel lab on Docker Hub, an OpenFOAM image with the v1912 tag and the command that I used to launch the calculation. So just take a little break here, see if there are any questions. There are not. Perfect, let's move on. Let's move on to buckets. So the buckets, like I said, are the storage that you have on Qarnot. So when you sync your case study, it will arrive here. So I have the OpenFOAM demo input, which, like I said, is the Pixlady tutorial. So I have all the classical OpenFOAM folders, the zero constant system, and the all run that I use to launch my calculation. And when and the results, they also appear here. So I have all the outputs. Some words on the buckets. We use the Amazon S3 like technology, so it is compatible with some tools that you can use to upload data onto buckets, so like S3 browser or CyberDoc. And you can also sync from the console here by creating a new bucket with a name and then uploading your data, or you can, of course, sync them onto Qarnot with a script from which can be any programming language. All right, let's move on to profiles. So if you have used other cloud computing providers like Amazon or Azure, on Amazon, profiles can be are just a little bit like AMIs. So they are how do I say? Sorry, they are templates that we use to store constraints that you can use, that you can call on, and then you can use to launch your computation. For example, if I take the Docker batch profile, it has a lot of commands of constraints that you can use and that you can specify when you launch your calculations. For example, like I said, you could pull a Docker image from a private registry. So here you can use the Docker server tag and write into it your IP address or your HTTPS address for your own Docker registry. And you have all kinds of constraints that you can use to launch your calculations. For our clients, you only have access to some public profiles, but if you need more precise stuff like access to other types of processors, you can talk to us and we will create profiles for you so you can use for your own needs. First, let's move on to doing a small test case on Qarnot. So to install Qarnot, it's pretty simple. You only have to follow these simple steps. So you have to create a virtual environment. It's better. It is not mandatory, but it's better to do it. So you create a virtual environment in Python, and then you only use a pip to install Qarnot. So I already have Qarnot on my computer. So I will show you how that works. The first case that we're going to look today is the hello world. So it's pretty simple. It's how to connect to Qarnot, launch a task and a hello world task and retrieve the results. So the first, can you see my terminal? I think you can, perfect. So I will go into Python. And the first step is to import Qarnot, which is already installed on my computer. So very simple, import Qarnot, that is done. Then we want to connect to the Qarnot platform. So we use this line here. So Qarnot.connection.connection, and then it is here that you put your token that you can find on your account. Just like I showed, if my screen was working, it is right here. You can use your API token. So instead of, and here I have it into a conf file. So I'm not showing my token to the whole world. So I will just put that line. So I am connected. I have created this con variable to connect to Qarnot. And then we're going to create a task. So very simply, we have con.createTask. We will call it hello world. We will use the Docker batch profile. So this is the default profile that everyone uses. And this number here is the number of instances that we want to launch. So in this case, let's try to launch 4 instances. So I will just copy that here. So that is created. And then the next steps, let's use the Docker command constraint to specify the command that we want to launch in our Docker container. So we're just going to echo hello world. Here you go. So that is the Docker command has been specified, and then after I can only do task.run, and the task will be launched on Qarnot. So just to show you, going back to my console and the task, you can see that the hello world task has been launched. Right now it is dispatching. So dispatching, it means that behind the scenes, the data. Well, there's no data here, but if there were any data, it will be uploaded onto Kernel and onto the infrastructure, and the computing nodes are being turned on, and it will take some seconds. But like I said, the wall time is increasing, but not the execution time, and you are only billed for the time it takes for the calculation. So the 33 seconds here of wall time, that is not billed. So it will take a bit, some seconds, and then after we will have the results that will appear in the std out, and we can retrieve that result. So I'm going to take the opportunity and look if there are any questions. What are instances? You mean cloud cores? Yes, that is exactly what it means. There are computing nodes. We have 3 kinds of processors, and we are going to have more that are even more powerful for CFD. Yes, there are computing cores that are located in the cloud. So right now, I think I'm only using a core for demonstration, but we also have 16 cores and 30 cores with 64 and 128 gigabytes of RAM, respectively. And it is successful. So we have the echo here, and then we can easily just print and retrieve that std out and have it on our terminal here. And there you go. This is the first calculation that we run on Qarnot. So I have a question here. What are the maximum instances that can be run? Does it changes the price to run the case? No, that is because Qarnot uses batch computing technology. Well, it's not a technology; it's a way of launching tasks. So it's batch computing. So you can launch a whole bunch of calculation at the same time. And no, it does not change the price to run. If I understand the question, it does not change the price. How many instances that you run at the same time? You will be billed per instance, but yeah, I hope that answers the question. So that is perfect if you have some parametric studies that you want to do, either in angle of attacks or wind velocity. You can launch a whole bunch at the same time, and it will all appear here, and it will be done at the same time. Perfect. So that was our first case. We can move on. If there are no more questions, we can move on to another example, which uses OpenFOAM. So I can just open right here the script that I use to launch our first OpenFOAM case on Qarnot. So this is, it may be a little dark, so I will change the fonts and colors. Classic. Perfect. So this is the script. I will go over it to show you how to launch an OpenFOAM case on Qarnot. So the first part is always importing Qarnot, importing the SDK, creating a connection with your own API token. Then we will create a task called OpenFOAM demo with the default Docker batch profile. And this time we'll only launch one calculation. Here I have the case on my computer. So it is like I said, the It's Daily tutorial. So it is right here in this folder with all the OpenFOAM folders and the all run. And I will go back to my script. So I will sync that Pits Daily folder with the bucket on Qarnot and call it OpenFOAM demo input. I will add that bucket to the task that I just created. And I will also call out an output bucket that is named OpenFOAM demo output. And after that, I will use our own OpenFOAM image, which is stored on Kernel Lab on Docker Hub. So the repository is Kernel Lab OpenFOAM with the tag v1912. And the command is simple. I would just want to run that all run bash file. And then I will submit the task, and then we will run on Qarnot. So let's try it. So I'm just gonna exit quick. See if I'm there. Yes, perfect. So I'm just gonna Python 3 and launch the OpenFOAM demo. And here it goes. This part of the script is just to read what is the status of the task. But you can also see that on the console. So you see that I have launched the OpenFOAM demo task. So it is dispatching. It could take some seconds to boot up the calculation node. It will do the calculation, and we will have the results in a couple of seconds. And if you have any question, do not hesitate. Here, how it works at Kernel. Our teams, we have many teams in our company. We have the development team, and we also have the we call the Q laboratory team. So that's the team I'm a part of, and we have a lot of engineers that are from many domains. Like I am from CFD, I have a background in aerodynamics. I have a colleague that is specialized in 3D rendering. So that is our job, to be close to our client and help them integrate their workload on Qarnot. And that's why we have people from different backgrounds, so they can really be specialized in their own domain of expertise. So that's it. The calculation has completed. I forgot to delete the bucket to show you how it was created, but this is the output. You can see here that the output bucket is the OpenFOAM demo output. So all the results are there. And we have our PITS-Daily calculation that is completed. Then you can download the results and open it on your terminal, onto PowerView, and do the processing analysis. Or you can we also have a ParaView Docker container that you can use if you want to visualize your results on a Kernel node. So if there are no more questions about this calculation, I can do that. I have a question. So how much the subscription cost to use Kernel? So we do not have a subscription cost. We only have the cost for the calculation. So you put credits into your account, and they are billed per the execution time of your calculation. If you want to know more about the pricing, you can contact me, and I will send you the pricing sheet for all the processors that we have here at Kernel. And which OpenFOAM version does it support? Like I said, that's the beauty of Docker. So you can almost create a Docker version of any version of OpenFOAM that you want. Here at Kernel, we have all the recent versions from v19 on the foundation side, and to v7 and v8. Did I mess up the organization and the foundation? Maybe I did, but yeah, we have all the recent versions, or you can bring your own version if you have some custom stuff in it also. So if there are no more questions, I can move on to the ParaView. just to show you quickly how that is done. If you want to use, we use Power View Web for our visualization. So here I have the same scripts that you use to launch calculation on Qarnot. So same thing. We want to import Qarnot. We want to create a connection with your API token. We want to create a task. So this one we call ParaView demo. We will use the ParaView web profile. So like I said, a profile contains the constraints that you will use to launch your calculation. So the constraints can either be the processor, it can be network settings. In this case, it's the Docker version that we will use. So it's ParaView web, and we will launch one instance of that ParaView web. So I will append the output bucket. So sorry, I didn't. So it was at the end of the order. Usually I put the ParaView at the end of the OpenFOAM calculation, but I decided to split it up into two parts. So it's really easy. I will task rows. I will input as the input bucket. I will use the output from the OpenFOAM demo. So let me see. I will append which input bucket this is. So I will just I think I just messed up something. Sorry, just give me a second. I will do it here. You can just relaunch it, and we will look at how the ParaView web works. I think to go back to a question, what are the maximum numbers of instances that can be run? I think you saw that there is a total number of instances. That is just the limit that I have on my account. But if you really need a lot of calculation that has to be done at once, that limit can be removed or be increased. Same thing for other parameters like the maximum running task. For now, I can only run 10 tasks on my account at the same time, but that is just a limit, and that can be increased or removed. And same thing for maximum number of instances and the maximum number of cores. And after that, that's gonna be about it. That's all you need to know to launch Qarnot, launch calculations on Qarnot. I'd say it's pretty simple. You have to with this, you only need a small script like in Python of a couple of lines, and that is done. So just to explain what is happening on my screen, we are dispatching the ParaView demo task, and it will give me a link that I can open on my browser. So to visualize the results of the pit study. It is still dispatching. I don't know what is. Here we go. So just copy this address onto the browser right here. This is, no, I will just proceed, and it gives you a user and a password to enter. So I would just copy there, and it will launch the ParaView web, which can then be used to visualize the results. Here you go. I have my pitsteady.phone, and here you go. You can see the results. That's it. So yeah, that's about it. I think I went a little bit quick. If you have any question, do not hesitate. Yeah, thank you for coming.